asset bundle compression. I think it uses Huffman coding. It's fantastic. We're actually pretty happy with it. If you've got a fast connection and a reasonable machine, it takes about 40 seconds over the internet, not just on our office machine to get into a game. We would like to reduce that, but that's not so bad. So, like I mentioned before, the game is a Unity Flash hybrid. So this loading screen, which you can see better down there, is actually completely Flash. When you're in the game, that's Unity. So I will talk a bit about that. First of all, when you're in game, we always have a Flash ad running because we've got to pay the bills. So Flash is always visible. One thing we would really love to be able to do is to render Flash in Unity. Near as I know, there's no C# or the scale form. There's no plan for any way to actually get Flash into Unity. That would be fantastic for us. You can't, because Unity is graphics accelerated, you can't render a Flash widget over Unity. Now, why would you want to do that? Oftentimes, you have video ads, which are all done in Flash, because advertisers who are displaying things to the web, they only think in Flash. Also, sometimes there are these ads, which I'm sure you've seen them on other websites, they expand and they go down when you click on. And we'd like to be able to show these because advertisers are our friend.
You say you can't do the Flash widget on top of Unity because you said something I didn't pick up.
Because Unity is accelerated, so it's typically going through the...
It's like reserved screen space, basically.
Right.
It just take a frame and start rendering into it.
The web browser doesn't necessarily know about that. It all depends on your particular browser, OS, and driver combination. Sometimes it'll work, sometimes it won't, but if you're trying to have a mainstream advertising supported site, you can't.
So you can't turn off that feature of Unity?
No.
It's an operating system. It just doesn't work sometimes.
It's not so much a feature as much as how it's written. How it's written. So, like I mentioned before, the loading page is a Flash widget. The Unity client is actually in control. It swaps between them. When that happens, either the Unity or the Flash widget, they're both always on the page. One of them is just a single pixel beneath what you're looking at. We did this all based on something called a 3D object with my Brazilian company called Akiris. I don't know if anybody knows or you see those guys. Yeah, they're great guys. Another big problem we had to solve in development is build. So anybody who's worked in commercial game development knows that you always have to have a really easy way for non-technical people to be deploying the very latest version of your game, so they can either test it or designers can iterate on it. And you don't, if every time somebody wants to get the latest game server, they've got to hold a programmer who's working on web services off to get him to kick a server, well, you'll never actually ship a game. So we actually have a build server. It's just a VM, but it's running in Linux, and it builds our Java server code, it builds our Groovy code in the website, it even compiles our Flash. And it's all a continuous build process. So every time somebody checks something into Perforce, we've got something which does a build, just to make sure the build didn't break. Every time QA wants to deploy to a test server, they can just click a button and get the latest. Now, what is the problem with this situation? Unity, obviously it doesn't work in Linux, and it requires a graphics card. Even if you do the headless build, just the command line build, it bombs out on initialization. This might have been fixed in Unity 3, by the way, but
Sort of is.
Is it? Okay.
You can build a mod at all.
Oh. We tried getting that to work in 2.6.
Yeah, it's a tool that didn't used to be a part of the Unity package and now is, and it's like Linux friendly and all that. So.
That would be fantastic. What we ended up doing is we have a physical build PC. And while that's not so bad in and of itself, we really wanted it to be part of this automatic build process because if every time QA wanted the latest Unity, they had to go and bug the engineer who had most recently checked something in to get the latest version, you'd be waiting forever. You couldn't develop a game that way. So how it basically works is we have a physical build PC, and we've got Stigwin on it, and we've written all these scripts so that we can go in and do a get from perforce, and then we actually copy them into a separate build directory. Why do we copy it into a separate build directory? Because Unity 2.6 will only build from a project that's already been set up. So even though we blow away all those files, there's nothing remaining in there. Unity 2.6 wants to have been configured to build from that directory. We build it, and then we copy the binary assets that are built back into the build server. It was a big pain to set up, but it's actually worked pretty well. The biggest problem we have is that when we're doing simultaneous builds, so oftentimes you don't just have one version of your game. For example, if you're readying a release, you may have the version that you're about to ship, and then you may have a bunch of other people working in trunk on stuff which isn't supposed to ship for another month. Well, if both of those builds get triggered at the same time, it can be really, really slow. It works, it's just really, really slow. We could fix it by having multiple build servers. We've also talked about using a Mac server. It's been more of a pain than a hindrance. The next thing I want to talk about is animation. So there's actually a really cool video that's not playing right now of football players running. So how do we get animations to go from a beautiful 3D animation that our artists created in Max to this, which is basically a sprite tile sheet, which is what a 2D client would use. The other issue is there are actual physical properties to these animations. So by physical properties, I mean when the quarterback throws the ball, you want the ball to leave his hand. If a running back gets tackled, the ball can't just pop out of his navel. That would look disgusting. So how do we solve this problem? So our source asset is a Max file. In Unity, that's easy because Unity has a Max import. So the world is a wonderful place. Now, all those physical properties I spoke about are actually created in our data build, which is just a separate part of the build process. Max actually has some middleware that lets you open up Max files and parse through all the different properties. It doesn't actually work all that well, but it works well enough if you tell your artists how to create their Max files. We parse through all those animations, and we actually generate Java source code. So now why do we use Java source code instead of going into XML or some other format to be read as data? Well, we do it because that's the fastest way to look through all this data at runtime. Every frame of every simulation, we want to know things like how far a player runs in his run cycle that particular frame. Clearly, the fastest way to look that up is if it's static data that's just compiled into the executable. It doesn't actually change all that often. Typically, when artists tweak the animations, they're changing the secondary motion on his shoulder. They're not making radical changes. So yeah, we do have an issue where an artist will update an animation, and then it has to, in order for him to see that, he has to wait for the whole thing to build before he can actually see it in the game. That hasn't been too much of an issue because rapid iteration on stuff like that hasn't really been too much of a bottleneck. The last part is, how do we get those tile sheets? And that's really hard. So what we do is we have a whole bunch of scripts written in MaxScript, which go through the animations and essentially render them with a camera point positioned directly above him at 15 frames per second for every single animation. And it doesn't actually end there because the difference between 2D and 3D is in 3D, if we want his jersey to look different, well, we can just change the texture. That doesn't work in 2D because a lot of the difference is you can't just dynamically color. The Bengals uniform has tiger stripes on it. The Patriots uniform doesn't have those stripes. The numbers are in different So we actually have to render out home and away for every animation. We have to render out versions in the home uniform and away uniform for every team in the NFL, and it's a lot. So we've got about 100 animations. So it's not a huge animation space, but we are talking about 6,400 tile sheets. The whole animation making process takes about a week from start to finish. Now, that sounds really awful, but in practice it's not, because in order for people to work on the game, they don't need to have all the animations all the time. You know, for them, we've played a lot of our reference render is Patriots home uniform. Imagine why that would be. And we've played a lot of games with the Patriots home versus the Patriots home. One other thing which I think is interesting, which you can't see on here, is how do you draw the numbers on the uniforms? Because in 3D, it's obviously simple. We just have a shader that when it's drawing that polygon, it says, oh, you know, the left number is a 2, so we'll look at the 2 part of this texture. But in 2D, obviously, you don't have shaders. How do you do that? Well, you'd actually have to bake it into the animations themselves. And to do that, instead of, you know, you need 100 different versions of each animation. So instead of it being 6,400 animations, it would be, you know, 640,000, which is a lot. So how did we solve this problem? When you play the game in 2D, everybody, as they're running around the field, is number 00. And nobody's ever I want to get into some of the things we did to debug the game. I'm not just talking about debug the code. In 2.6, we didn't have a debugger. That was very complicated. I'm also talking about the fact that when you're making a network game, it's just a very hard problem. You have lots of different tiers that have to be moving in sync, and a problem in any one of those can cause huge issues. So the most useful thing we've done is in the game we actually have a debug display, and this only works on internal servers. Now again, this seems totally obvious. Why wouldn't everybody do this? Well, the first version of the game didn't do anything nearly this useful, and it took many gray hairs before somebody, maybe somebody in QA, was like, can't you just like display the state that we happen to be in? So we display the state in the top right hand corner. So now why is that tricky? The thing about a multiplayer network game obviously is your client can change the state. You know, you're in play calling, you pick a play, all of a sudden you're waiting for the hike to happen. Well, what if both clients want to change the state to different things? Like I select a play, but my opponent calls a timeout. Intuitively, you just say, well, I mean, he called a timeout, so you call a timeout. But the problem is, depending on what's, you know, the server can be any one of many different states, and you don't know what order those messages will arrive at. So even though intuitively it sounds very simple, there's actually a lot of branching in that problem. And the problem is, it tends not to be the states you think about easily, like somebody called a timeout when somebody else is calling a play. It tends more to be like the situations like, oh, it's the end of quarter, and somebody called a timeout, and then, you know, my client's waiting for the server to be like, hey, I called your timeout, whereas his client